Hello, everyone, and welcome to EdSofta's Chemistry JAMB UTME tutorials. And as we all know, or as we've been saying, EdSofta is an edtech startup that specializes in creating for creating software solutions for education. So we have software solutions for JAMB, for UTME, for WAEC, for for education as a whole. Software Ed Software is we have Ed Software has an app for UTME, and our app has past questions, study materials, and other features that help students to prepare for the exam. For these tutorials, we will be solving questions from the EdSofta app. Visit Google Play or your Android phone. If you want to download the EdSofta app, you can visit Google Play on your Android phone and search for EdSofta UTME, install it, and to use the full features, you need to activate it a for just 1,500. Then also, if you want to use it on your laptop or your Windows laptop, you can go to our website and download the setup from our website, install it on your Windows platform, and also you can activate it for a sum of 1,500. So today we'll be talking about chemistry. My name is Samuel Okwe. I'm a staff of EdSofta. We'll be talking about chemistry, and particularly during this tutorial, we'll be talking about um, chemical equations. We're talking about chemical equations or balancing of equations, as the case may be. Now, chemical equations are a representation of chemical reactions in terms of symbols and formulae for the elements and compounds involved. So, scientists discovered that they could, create new substances. This all comes from the two types of changes that we have. We have physical changes and chemical changes. Physical changes is more or less like the ones that we can see. So, change in shape, change in size, change in you know those things that you can see, boiling, change in physical state. So that's even change from solid to liquid to gas. But we now have chemical changes, which now tells us how substances behave when they combine with other substances to give us new substances. So take for instance, now you want to synthesize or you want to create water. For you to create water, what you have to do is you have to react your hydrogen with your oxygen to give you water, because we all know that the formula for water is H2O. That's it has two atoms of hydrogen and one atom of oxygen. So chemical equations are now what we use to represent this chemical reaction in terms of symbols and formulae, just to help us to reduce the bulkiness, so that it's not so bulky, so that instead of just writing oxygen plus water, and also to help us to perform certain how do I put this, certain um, arithmetic on them, basically just to help us to perform certain arithmetic on these chemical reactions, so that we can know how these substances behave when they react with each other. Now, a chemical reaction, an example of a chemical reaction is A gives C plus D, where A plus B, so the things that come together to give these new substances are called the reactants. The things that come together to give us these new substances are called the reactants. While the substances, the substances, while while the substances while the substances that are created, the substances that are made are the products, while the substances that are created, the substances that are made are the products. That's C plus D. Now, reactants and products are linked together by an arrow symbol whose head points towards the product. So this is a perfect example of what a chemical reaction looks like. This is a perfect example of what a chemical solution looks like. So let's go on. A chemical equation is of little value if it's not a balanced equation. So now it's not just enough for us to have a chemical equation. It's not just enough. We now need to have a balanced chemical equation. Why? Because we will not be able to we will not be able to explain we will not be able to explain some certain ratios when we don't know the balanced equation. So as we all know, when gases react or when elements react together, they do so in small ratios, as Gay-Lussac has told us. And these ratios, we say they are in small whole numbers. And so for us to actually have accurate ratios, we need to balance the equation. When an equation is balanced, the total number of atoms of any element on the left-hand side of it must be equal to the total number of atoms on of that element on the right hand side. So this is just telling us that this is just a form of way to sort of explain the theory or the law of conservation of mass, which is saying that there which is saying that there must the mass of the reactant must be equal to the mass of the product. So there's no mass that is going to be lost. Just like the law of conservation of energy, there's no energy that is lost. Energy is just transformed. Just the same way mass also in a chemical reaction, there is no chemical that is lost. There's no mass that is lost. It's just that the chemical reaction has transformed the mass to a different kind of mass. That's why when you add hydrogen and oxygen together, you don't lose any hydrogen, you don't lose any oxygen. What do you get? You get what? Water. So for an equation to be balanced, the total number of atoms of any element on the left hand side of it must be equal to the total number of atoms of that element on the right hand side. So let's switch to the board so that we can see an example of what I mean. So I'll be switching the screen to the board. Okay. So now, so take for instance, you have something like this: hydrogen plus oxygen should give H2O. Now, if you look at this one, these are classic. This is a chemical equation. But like we said, a chemical equation is of little value if it is not balanced. So you see here, you have two atoms of H, two atoms of oxygen, but you only have one atom of oxygen here and two atoms of hydrogen. So what it's telling us is that this is balanced, but this is not balanced. So what do we have to do? If this is 2, that means we have to put 2 here. But now when we put 2 here, it means that this one is not more balanced. So what do we have to do? We now put what? 2 here. So now we have a balanced what? A balanced equation. We have a balanced equation. And this balanced equation now has more value to us because we know that, okay, anytime that you want to synthesize water again, you know you are going to use twice the amount of hydrogen for one amount of oxygen. So you see, we have the right ratio, 2 to 1 to 2. But if we did not have this, we don't have the right ratio. So what we'll just be doing is that we'll just be synthesizing rubbish. So this chemical balance, chemical equation, balance chemical equation gives us the ability to know the ratios, know the exact ratios, and it gives us more value. It makes it easier for us to synthesize this reaction in a lab, because we now know that for this reaction to occur, there has to be twice the amount of hydrogen, as you can see, that it is 2:1. So let's go back to the slide so that we can continue. Let's go back to the slide so that we can continue. So writing chemical equations, writing chemical equations, writing chemical equations. The first step in writing a chemical equation is to ascertain the product of the reaction in question. For example, hydrogen reacts with oxygen to form water, and the equation is written as H2 plus O2 is H2O. This equation is not correct quantitatively, as it violates the law of conservation of mass. Although the two hydrogen atoms are indicated on both the left hand and the right hand side of the equation, the two oxygen atoms appear on the left hand side and one oxygen atom appear on the right hand side. This number of oxygen atoms are not the same, hence the equation is not balanced. So now, what are the things to note when balancing equations? The things to note when balancing equations. Equation must be balanced through the use of coefficients in front of the formulae and not by changing the subscript numbers within the formulae. So this is I would like to shed more light on this. So let me just switch to the board. Okay, so everyone, so what that is telling us, let me see if I can read it again. It is saying that equation must be balanced through the use of coefficients in front of the formulae and not by changing the subscript numbers within the formula. So what this means is that you have you have your equation that you want to balance. You have H2 plus O2 to give us, sorry, to give us H2O, to give us H2O. So now we are now asked to find this H2O. You're now asked to balance this equation. And you know that you have H2 plus O2 is give us H2O. You know that what you have to do is to what? Add 2 here and add 2 here for what? The equation to be balanced. But now you don't go ahead and say no, you will not add 2 here. What you now want to do is now that you want to add 2 here and change this one to 4. Why you change this, put 2 here, I don't change this one to 4. This doesn't work. So that's what that statement means, that you don't change the values here. To balance equation, what you use is what? Is the coefficient. Is the what? Coefficient. The coefficient. That's the numbers in front of the element symbols. That's the numbers in front of the element symbols. You don't use the you don't use this. You don't use this one. You use what? The coefficient. So let's move on. Let's see the other things to note. So I'll be switching back to the slide. So equation, next, common gases such as hydrogen, oxygen, nitrogen and chlorine in the free state are diatomic. Yes. So hydrogen, oxygen, they are usually H2, O2, N2, Cl2. Your common gases are usually diatomic. Diatomic means that they have two atoms in their own elemental state. They have two atoms in their elemental state. Now, other elements such as sodium, potassium, even sulfur, even carbon. So these elements, mostly metals and some other elements in group 4 are are usually in monoatomic states. So they just stay as Na, no subscript. They just stay as potassium, no subscript. They just stay as copper. So it's just Cu, it's just P, it's just K, it's just Na, it's just Fe, it's just S, it's just C. It's not C2 or Fe2 or Na2. No, they are what? Monoatomic in their elemental state. Now, in simple chemical reactions, in simple chemical reactions, radical remain so the next one is, in simple chemical reactions, radicals remain unchanged during the reactions. In simple chemical reactions, radicals remain unchanged during the reactions. In simple chemical reactions, radical remains unchanged during the reaction. So this one is just telling us that when you have stuff like NO, NO32 minus, SA42 minus, nothing really happens to the radical. It is still going to be Na42, Na4, SO42 minus, Na3, NO32 minus, like that. But let's move on. So these are the things to note when you are dealing with chemical equations. The things to note when you are dealing with chemical equations. So let's go over it again. Then we can take some questions and then we'll come back for another. We'll go on a break and come back for the next topic. So chemical equations are representation of chemical reactions in terms of the symbols and formulae of the elements and compounds involved. Reactants are written on the left hand side, while products of the reactions are written on the right hand side. Reactants and products are linked together by an arrow symbol whose head points towards the product. As you can see there, A plus B is the reactants and it goes towards C plus D. Reactants and products are linked together. Okay? Chemical equations is of little value if not balanced. So yes, we have explained that chemical equations is of little value if not balanced. When an equation is balanced, the total number of atoms of any element on the left hand side of it must be equal to the total number of atoms of that element on the right hand side. The first, writing chemical equations. The first step writing is to ascertain the products of the reaction in question. For example, hydrogen reacts oxygen to form water and the equation is written as. So now this is saying that before you write any chemical equations, know the formulas, the symbols of the reaction of the reactants first. Then you can now move on to knowing the product. So always know the product, know the the reactants, know their symbols, then you can now write the equation, then you can now talk of how whether the equation is balanced and how to balance the equation. So let's look at some examples. I will be putting them on the board, then we'll be looking at how we can we can balance some of them. So let's move to the board. Sorry about that. So we have a very interesting equation here. So we have a very interesting equation here. Let's just be so we have copper is reacting with HNO3. So we know we have three, we have Cu, sorry, Cu plus HNO3 is reacting to give us CuNO3 into bracket 2 plus NO. Sorry, let me write it in a smaller way so that we can continue. Cu plus HNO3 is reacting to give us CuNO3 in bracket 2 plus NO plus H2O. So now we want to see how we can balance this equation. We want to see how we can balance this equation. So if you have any questions, feel free to just comment, just comment because I am seeing the comments here. All right. So how do we do? First, let's look at it. How many? So we can see that our copper is balanced. We have one copper here, one copper here. Here we have two hydrogen, one hydrogen. We have one N, two N, because these two multiply this N, two N, that's even about three N. So two N here, one N here, that's two N. So that's about three N. Then this is six, and this is what? An extra one, six. So we have about, so we know our copper is balanced. So now the first things we have to do is, what's the next element that we can balance? So we ask ourselves, what's the next element we can balance? So let's say we want to balance H. Let's say we want to balance H first. So to balance H, what do we do? Let me switch it to another pen. So we know C is balanced, but we want to balance H. What do? We can add 2 here. Wow. The moment we add 2 here, our H is balanced because here is what? H2, right? But now, what's the next element? Nitrogen. Our nitrogen is not balanced. We have 2N here. We have 2N on one side and 1N on the other side. What can we do? How can we balance this equation? Now, it means that we are going to have to change what we are using for the N. So what I would suggest is, if we add 2 here, So now you see, it is not, there's no straight way or way of you balancing. It's just you just keep looking for a way to make sure that they are what equal. But it's best to start from the first element and you go down to the last element. So see here now, we have two here already. We only have this one that is making it not to be even. So here the nitrogen is even. So let's add two here. If we add two here, we know that what this one becomes even, and we have 4 nitrogen on this side. We have 4 nitrogen on this side and 2 nitrogen on this side. So what can we do? We can what? Equally change this our 2 here to what? 4. We can equally change our 2 here to what? 4. Now, on changing our 2 here to 4, what do we have? We have 4n here. But look at our H. Our H is 4H, and here is still what? 2H. So what do we do? What do we do? We can change this to what? An extra 2. We can put an extra 2 here. And based on this, we have our balanced H. We balanced our copper. We balanced our hydrogen. We balanced our nitrogen. Because if you can see it here, we have 1 copper, 1 copper. 4 hydrogen, 4 hydrogen, because of 2 times 2. 2 times 2. We have 4 hydrogen, 4 hydrogen. 4 hydrogen, 4 hydrogen. 4 hydrogen, 4 hydrogen. 4 hydrogen, 4 hydrogen. You understand? For nitrogen, we have 2 nitrogen here, 2 nitrogen here. So it's now what? We are now on the what? We are now on the oxygen. So how many oxygens do we have here? This is 4 times 3, 12 oxygens, 12 O. Here we have 6 O and 2 O. So we have what? 8 in general. So what can we do to what? Increase our chances of having up to. How can we do to increase our chances of having up to the required amount of O? So we even have, oh, that's even true. We have another extra 2 O here. That means we have 10 oxygen on this side. We have 12 oxygen on this side, 10 oxygen on this side. So what can we do? So we can obviously just do this. We can increase the number of hydrogen here, since we know that it may not have so much of a bad effect. We can increase the number of hydrogen here to 4. If we increase the number of hydrogen here to 4, what happens in essence is that the oxygen becomes balanced. So the oxygen is balanced now. But it affects what? The hydrogen. As what we have here now is what? 4 hydrogen. And here we have 8 hydrogen. So what do? We balance this one again to what? To the number of hydrogen. So what do? We add what? 8. Because so that it will have 8 hydrogen here, 8 hydrogen here. So now we have our balanced number of hydrogen, 8 hydrogen, 8 hydrogen. But now we are faced with a monster where we have, instead of having, we have 24 oxygen. And here we still have our what? 12 oxygen. But now we can't afford to, change this one again. Why? Because the moment we change this one, we have to change the hydrogen, so it has no effect. So changing this one has no effect. So we just leave the H2O the way it is. Leave the H2O the way it is. We know that our hydrogen is balanced. So we now look for here, what can we use to balance this? Let's look at our nitrogen. We have 8N here. And at this place, we still have what? 4N. So what can we do to balance our nitrogen? Now, what we can do in essence is, if we increase the number of nitrogen here, there's no amount. So we have 8N here, we have 2N here, we have 2N here. That means if you make this one 3, it becomes 3n. It does not really have any effect on the equation. So that means the only person that we can change is the what? Is the CU. This is the only person that we can affect. And how can we affect the CU for it to give us 24 extra oxygens? What we can do is to what? We see we have 6 oxygens here already. So what do you need to multiply to this 6 to add 12? 6 plus 12 is what? 18. So what do you need to multiply to 6 to add 12? You need to multiply what? 3. And by the time you multiply 3 here, you have what? You have 18 oxygen here. You have what? 12. You have 2 oxygens here, and you have 4 oxygens here. Your oxygen is balanced. Your oxygen is balanced. Your hydrogen is balanced. Your nitrogen is also balanced because this becomes 6 nitrogen and this is still 8 nitrogen. So the only person that is left is the single, is what? Is the copper. And how do we balance the copper? By just putting 3 here, and we have our balanced equation. Sure, it takes a while to balance the equation. This, but what is important, what is the first thing you need to know is that the both all the elements on each side must be equal. All the elements on each side must be equal. All the elements on each side must be equal. If you can look at this very well, you see you have 3 copper, 3 copper. You see you have 8 nitrogen, 8 nitrogen. You see you have 8 hydrogen, 8 hydrogen. You see you have 24 oxygen atoms, you have 24 oxygen atoms here, and the equation is balanced. So what is very, 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 very important is that we ensure that the number someone is asking, sorry sir, will you still illustrate us on ionic alkene alkene organic chemistry? Please, the question is not very clear. Please, can you say it again so that we'll see whether we can put that in? Okay, so let's go on. Let's go on. So this is just telling us, this is just a little, this is just an equation that we have balanced. So what is important is for us to note that what? The element on the reactant element must be equal. Must be equal. I repeat, must be equal to the product element. The reactant element must be equal to the product element. Let's see whether we can take one more before we call it because we have other to do. So let's take a more familiar one. A more familiar one. A more familiar one. This is quite easy. This is the decomposition of NaHC. This means decomposition. This is quite simple. So what you can see here is you have 2 Na, you have how many C? 2C, you have 6O and 2H. Here you have 1 Na, 1C, 1H and 3O. This is quite very simple. If you can see it, congrats. because you can see that everything here is double this one. Everything. So T double this one, H double this one double this one. So all you have to do is just to put the coefficient to. Now, this is very important because a lot of the questions that you are going to be given or more ratios and reactions where they tell you that okay, what is the find the mass of something if this reacts with this. All those questions, even your solubility questions, they are going to hinder on what you balancing your equations. So you knowing the formulas, you knowing the formulas, you knowing the symbols of these elements and these compounds cannot be overemphasized. You knowing the formulas, you knowing the symbols of these elements cannot be overemphasized. Why? Because 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 you need to know it for you to be able to fathom the what, the reaction. So if you are given something that you say and they tell you that sodium triisocarbonate reacts with HCl with hydrogen chloride to give sodium chloride plus carbon dioxide plus hydrogen plus water, and you don't know the formulas of this each one, it will be difficult for you to even write the equation, talk less of balancing the equation. So your naming, your IUPAC naming is important. You have to know the names of these compounds. You have to be able to convert these compounds from their names to their symbols so you can write out the equations and balance the equation so you can get the mole ratios of this equation, and it can help you to do what? To solve the problems that these equations come with, or that arises with these equations. So I hope we have learnt um, a bit about balancing equations and what balancing equations entail. So this tutorial is brought to you by EdSofta, and EdSofta, like we said, I said it at the beginning, it is okay. So you are saying, are we going to do, if I'm getting it right, somebody asked a question, are you still going to illustrate us on ionic organic chemistry alkane? Well, for this tutorial, we are not doing organic chemistry yet, but I will tell you if we are going to look at organic chemistry alkane. But even if we're not going to look at organic chemistry alkane, we can just talk about it a bit, maybe in our last tutorial. But then, what do you mean by ionic organic chemistry alkane? Please, you can comment on, because we're going to start having another tutorial in like 15 minutes. You can comment on that. Okay. Talking about, so back to where I was. EdSofta a is a EdSofta is a software education company. We build solutions for software. We have a JAMB UTME app, and this app will help you to prepare, as there are explanations to questions. There are explanations to questions, to answers of any question that you practice on this exam. So please just go on the app, download the app, and you can use the app. Thank you, and God bless you. We'll be back in the next 15 minutes by 11:15 for the next topic.